In this video, we're going to take a look at how we can see if something exists in an array. Now, there are a few different ways we can get this done, and in this video, we're going to make the transition from an array of strings in both cases to an array of objects, because a note isn't just a string. A note probably contains other pieces of information we want to model as well, like a title, a body, maybe when the note was created, who created it, all sorts of different information. And the same with a to-do. A to-do is not just a string. It might be assigned to a specific date or a specific user in your application. It might be completed or uncompleted. So these are all things we want to associate with each item, not just some string data. Before we switch things up though, I do want to explore a couple of features down below. Let's say that we are creating this application and we have our list of notes, and now we decide that we want to find if a note exists or maybe locate it so we can do something with it, like delete it. The way we get that done is using the index of method, and it's super easy to work with. You just access it on your array, notes dot. We type it out, index, uppercase O of, and then we pass in the thing that we're looking for. So in this case, let's say we're looking for an item in this array whose value is a string. So we'll open some quotes, and it contains note 2, for example. This is going to return a number. It's going to return this item's position in the array. If there are multiple strings with note 2, it'll return the position of the first one. So if it was the first item, we would get 0 back. If it was the second item, we would get 1 back. And if it doesn't exist at all, we get -1 back. So let's see this in action. Console.log. Around both sides of our index of call, I'm going to run that script, which is node notes.js. And when I do, we're looking at the very last log. This is the number 1 showing us that it is indeed right there as the second item in the array. Now let's switch that up. Let's say, for example, I change it to a lowercase n, in which case it's not going to find a match. In this case, over inside of the terminal, I would get, as promised, -1. So when we see -1 from index of, we know that the item you searched for was not anywhere in the array. If we get any value greater than -1, including 0, then we know the item is indeed somewhere in the array, and we could go ahead and do something like remove it or modify it to fit our needs. And now let's go ahead and see how switching things over to an array of objects is going to affect this behavior. So up above, like I mentioned earlier, we're not going to have strings as the individual array items. Instead, we're going to have objects. So how would we do that? Well, we just define a new object right here in those square brackets. I could define 1 object, 2 objects, and 3 objects for the 3 notes. Now, the formatting that we typically use for this is to hit enter inside of each set of curly braces, and that brings us to something that looks like this. While this syntax might look a little weird at first, working with arrays of objects is so common in JavaScript that you'll get used to it in no time. And in here, inside of each object, we can define the properties that make up that object. In this case, the properties that make up each note. And we're going to have 2. We're going to have the title, and the title is what we had before. It's all we had before. So a title for the first note might be something like note 1, or in this case, I could say my next trip. Let's say I'm planning out a vacation. Now, aside from just the title, we're also going to add other properties onto the note. And the other one that we're going to add for now is the body of the note. So what is the actual text value of the note? And I could just say something like, I would like to go to Spain, something I'll likely be doing this summer. Now, this is just one of the notes. We're going to go ahead and crank out 2 others as well. So title. Right here, I could say habits to work on, and then maybe I'll list out some things I'm trying to improve. I could just say exercise, and I could add another one right here, eating a bit better. Perfect. And we'll crank out just one final note. So down below, title. And this one will be office modifications. And I'll just say something in the body like get a new seat. So go ahead and crank out 3 notes for yourself. And what we're going to do is explore how changing things to an array of objects affects the behavior of what we've explored so far. First thing to note is that all of the methods are still available. It's still an array. So we can pop off the items, we can push new items on, we can shift and unshift, although in this case we would likely push an object as opposed to a string, since that's the structure we're now working with. We can still modify our array items, and we can still use for each to print everything out. What I want to do for the moment, though, is comment out all of these lines, leaving just a couple of console.logs in place to clean up the output. Now, what we're going to do is figure out exactly how index of is going to work with an array of objects. So let's say I have an empty object. I'm going to add one right on here. Empty object, comma, space. Then down below, I search for the empty object. So right here, I remove the string, and I try to see where in my array I have an empty object by providing one right there. I then save the file. I'll clear the terminal output to clean things up and rerun the script. When I rerun it, what do I get? I get -1 printing. Right above, though, I do see my array. I have my empty object, I have my next trip, habits to work on, and office modifications all showing up correctly. So what exactly is going on here? To explore this behavior, let's go ahead and refresh our memories by opening a file we created in the last section. The file was objects references. And when we went through this video, the whole point was to show you that when we pass an object to a function, what we get access to isn't a clone of that object with the same properties. It's a reference to the exact same object in memory, which means that if I were to change account.expenses, we would be changing the original object that was passed in as the first argument. In this case, down below, that was my account, and we did indeed see my account change. We mentioned that this object is stored in memory, and what my account stores is a reference to this object's location, and the same is true with account. That is why a change to 1 is reflected in the other. So let's go ahead and bring this back to what we just explored over in notes.js. The index of method works by going through your array from beginning to end and checking if the item it's currently looking at equals the item passed into index of using triple equals. If it finds a match, it returns that index. If it gets all the way to the end and it doesn't find a match, it returns -1. We already saw that. So if it uses triple equals, we know that something like 1 equals 1, but what about an empty object equaling another empty object? Well, we can go ahead and figure out exactly what happens by saving the file and rerunning things, but the very fact that I'm actually saving it and rerunning it should likely believe you to know that the expected answer is not the one we're going to get. And that's true. What we get is false, not true. So when we're comparing two objects, it does not matter if they have the same set of object properties and the same object property values. That does not make two objects equal. What makes two objects equal is if they're the exact same object in memory. So let's see what that might look like. Let some object equal an empty object. Then we let other object equal some object. So like we explored previously, we have an object stored in memory. Some object is a reference to it, and then later on we make other object a reference to it as well. Now let's go ahead and switch up our equality operator. I am going to check if some object triple equals other object. Now we can go ahead and save notes.js, and over here inside of the terminal, we can go ahead and rerun the script. This time around, we get true showing up. So objects are only equal to other objects if they are actually the exact same object. It does not matter if two separate objects have the same properties with the same property values. Now we just proved that that's going to break index of for our purpose. And I mentioned that arrays of objects are super popular. So why would this super popular structure, an array of objects, not be able to use basic methods like index of? Well, the truth is we can't use index of. But in the array methods list, there are a whole bunch of methods specifically designed for use cases like this. So let's go ahead and explore an alternative way we can get the index of something in our array, knowing that that something is an object. Let's start by deleting these 3 lines, though I will leave the other console.log calls in place. And over on the MDN documentation, we're not looking for index of, which we already explored right here, that always uses triple equals when comparing the item passed in with the item in the array. What we're looking for instead is something that gives us a bit more flexibility. That's going to be find index. In the end of the day, we're going to get the same thing back, the index, or -1 if it didn't exist, but find index is going to allow us to work with our array of objects. Now, as we can see in the example, yes, it works with all sorts of arrays of any type. Let's go ahead and see how it does that job. I'm going to switch back into the terminal and then over to Visual Studio Code. And right here, we're going to kick things off with a call to notes.findIndex. Now, the call signature for findIndex is going to look very similar to what we explored with for each. What do we pass into findIndex? We pass in a function. This function gets called one time for each item in the array, and this function right here gets called with the individual item. Since we have an array of notes, I might call this item a note, and we get access to the index of the note that we're currently working with. Now in here, we can just console.log the note to prove that this is going to go through all the items. I'm going to save things in its current state, and over in the terminal, I'm going to rerun the program. But this isn't particularly interesting seeing our objects print, since for each does the exact same thing. This isn't the goal of findIndex. The goal of findIndex is to actually find the index, and unlike for each, it has a meaningful return value. So right here, const index equals, and then we could console.log the index. Console.log index being either -1 for no match or the actual index if there was a match. Let's go ahead and clear the output in its current state and rerun things to see what we get. Right here, we get -1. Now we're getting -1 not because the thing we're looking for hasn't been found, but because we haven't really set up findIndex to work as it's supposed to. With findIndex, what we do is we return either true or false. If this item isn't the thing we're looking for, we return false. If it is the thing we're looking for, we return true. So let's imagine I'm trying to find the note where the title is Habits to Work On because I want to read it or delete it or something along those lines. What I do is I return. I look at note.title, and then I see if it equals something else. So in this case, the string habits to work on, which is indeed an exact match with what we have above. Let's go ahead and see what happens when we save the file in its current state and rerun things. For clarity, I will clear the terminal output and rerun the script. And what do we get? We get 4, we get our array, we get our objects printing, and then down below, we get what we really came here for, which is indeed the index. We've got 2 showing up, meaning it was the third item in the list, and it was indeed the third item. Right here, we have our little empty guy, which scooched it from the second position down to the third position. Now you'll notice something interesting about the output. Now it doesn't have to do with the first 2 console.logs. It has to do with what starts when findIndex runs. That is all of this stuff down to the very end. We get our empty object, which is expected. It wasn't a match, so it continues on. We look at my next trip. It wasn't a match, so it continues on. We look at habits to work on. It was a match. We then get our index, and you'll notice that we never actually run this function for office modification. findIndex looks for the first match it finds. When it finds that, it stops running the function, which makes this efficient. If I have an array of 1,000 items and the second item in the list is the one I'm looking for, we don't have to spend the computational power to go through the other 997. Getting through this video took a bit more time than I thought it would, so we're going to go ahead and consider this part 1 of 2. In the next one, we'll continue looking at arrays of objects and finding items in an array, and it'll also include some challenges for you to actually go through with the to-do application. For now, though, let's take a quick moment to recap. In this one, we learned about index of, which uses the triple equality operator to go through our array and find an item. We saw that work with an array of strings because a string like S is indeed equal to another string S. This is true with strings, numbers, and booleans, but it is not true with objects as we saw. So we weren't able to use index of to find the item in the array of notes. Instead, we used findIndex. Instead of using triple equality on the entire object, we can specify our own search criteria. In this case, the search criteria was, does this title match this string? In this case, we are able to use the triple equalities because one string does equal another. Let's go ahead and remove this empty object up above, and I will see you in the next video, which is part 2 of this one. Let's jump right into it.